All right, so we're gonna factor and simplify the expression. So go back to algebra 1. A lot of y'all always forget what factoring is. That's the whole little big X thing. And in the top, we're gonna put A times C, and B is gonna go in the bottom. So just a reminder, when we have a quadratic, this is what it is in standard form. What's my A here?
1.
Okay, and then times C.
Negative.
Yeah, -8.
And then B is
-2.
just let him live his best life. Okay, so AC, we need two things that multiply together to get me -8, B, and add together to get you -2. What are you gonna say? Okay, so -4 and 2, right? -4 plus 2 would give me -2. With me? Yeah. Okay, so we can rewrite this as x minus 4 times x plus 2. But in the bottom, we can also factor this guy. So we're going to do A times C, which is going to give me 6. B is 5. So what two things can multiply together to get me 6, but add together to get me 5? 2 and 3. Okay, so we got x plus 2 and x plus 3. Is there anything in the top and the bottom that repeats? Okay, so we're going to cancel that out. And what are we left with? Ta-da. So really quick, I know a lot of us struggle with like the two numbers that multiply together and then add together. Okay, let's go back to this first one. We multiply together to get me -8. Okay, so what I'm going to do is I'm going to show you a little cheat code that I use. Yeah, cheat code. Big fan. Called Desmos. Yeah. So what you're going to do is you're going to take -8 and divide it by x. Okay. Now, you're going to go to your table, and this creates all the different versions of factors that would multiply to get you -8. Okay, so what? We got 1 and -8. That multiplies to get me to -8, right? But does it add together to get me -2? No. So I go to the next one. 2 and -4. That multiplies to get me -8. But does it add together to get me -2? Yes. So those would be my factors.
Say it goes like 5. Put 5 over x.
5 divided by x. And this is going to give me all the factors. Yep. And this will give me all the factors. And if you don't have enough, you can add on to that table. And you can only use whole numbers. So if it's a decimal, it's not going to work. Yeah. Okay. So today, we're going to understand the impact of holes and vertical asymptotes. So what you're going to title this? What you're going to title this is holes and vertical asymptotes. Yes, it'll make sense in a second. Like a hole.
Asymptote.
Yep. Great. So what do you notice or wonder about the two functions below? So this was the first thing that we had at the beginning. Where we simplified. What did we simplify this guy to? Okay, so we simplified that down to x minus 4 and x plus 3, right? Which is the same thing that's over here, right? Okay, so my question is, do these graph the same? Why would you say that? Yeah, but it's different numbers, right?
Yeah, but if you have like 8, x equals 8, x equals 4 times 2.
Okay, so, yep. No, this is just two different functions. We're just calling it two different functions. So that's what we're going to look at today. Do they graph the same? Y'all are saying, yes, they do. Okay, which is partially true. So what I want you to look at, okay, what similarities and differences do you see between the graphs? On the left-hand side and on the right-hand side. They look roughly like the same graph, right? Okay, so same shape. Is there anything different about the two graphs? Quit a little bit more.
I think the one on the. X minus 4x plus 3
Okay.
is like.
Hmm, Let me point something out for you. Hmm. So they are the same graph. I'm gonna tell you that. There's one difference though. What did it's that dot. Okay, and the reason why there is a difference is, you remember when we factored this first one, we got x plus 2 times x minus 4, and then x plus 2 times x plus 3, and then what did we do? We removed the x plus 2. Well, what's x plus 2 in graph form? -2, right? Well, look at where this hole is at -2. Okay, so there's a hole at x equals -2 for f of x. Yep. So we don't have a y value for that, because if we plugged in -2 into this equation, it wouldn't work. It would be undefined. To be where something approaches but never touches. And how do you find them? This is going to be in the denominator. Okay, and I'm going to show you what that is in just a second. Holes are going to be where the x value does not have a y value. And that's going to be what you cross out after factoring. Look at that handwriting. Yes. Doing great. Okay, so with domain restrictions, so with domain for this, we're going to say all real numbers, and then we'll say something like x cannot be, and then whatever the holes or vertical asymptotes at. You do what? A times C is going to be 9. B is going to be 6. What two numbers can I multiply to get me 9, but add together? There you go. Beautiful. So good. Okay. So this is going to be x plus 3 times x plus 3. On the bottom, we're going to factor this one. A times C is going to give me -9, and there is no B value. So what two numbers can I multiply together to get me -9, but add together to get me 0? Somebody said it.
Oh, -9.
-3 and 3. Okay. Now, my question to you, is there something on the top and the bottom that I can cancel? Okay. Okay, and you can only do one of them. You can't do like, I see that there's 2 in the top. No, it's 1 in the top, 1 in the bottom, right? Okay. Here's the important part. Ready? What we just canceled out is the whole. So we're going to take x plus 3 and set it equal to 0 and solve. Right? Now, in the denominator, whatever is left over, that is going to be what we call a vertical asymptote. So we're going to take x minus 3, set it equal to 0, and solve. And I'll give you a second to write that down. Okay, so we had some good questions really quick, and I just kind of want to go over those. Somebody asked, why is there a 0 on this bottom? Because there is no B value in the denominator. Okay. Another thing It's where you cancel, that's gonna be a hole. If you don't cancel anything out, then there's not a hole in the function. Okay? Not saying it's just a function. It just doesn't have a hole in the graph. The vertical asymptote, not every single thing will have a vertical asymptote. Okay? All right, go ahead and take a moment. I want you to try this one. In the top, this is a little different. Oi. Shh. Okay, on the top, this is a little different from how we factored previously. What is the greatest common factor from negative 2x plus 8? Negative 2. And so when we divide this, this is going to give me x minus 4. So I've done the top for you. Can you do the bottom? Okay. So we're going to factor a times c is going to give me 8. B is going to give me negative 6. What two numbers can I multiply together to give me 8, but add together to give me negative 6? Negative 2. Fantastic. So this can be x minus 2 and x minus 4. What can I cancel out? X minus 4. Okay, so that's going to be a vertical asymptote or a hole? Hole. Okay, so there is a hole at x equals 4. Okay. In the denominator, we have an asymptote. Okay, so we're gonna have at x equals 2 for our vertical asymptote. So I want you to take a moment. Okay, ready? I want you to take a moment on 10 and 12. I want you to tell me what the vertical asymptote is and the holes are. Okay, so go ahead and take a moment, right? I'm gonna start talking through 10 and then we'll go to 12 in just a second. Okay, so I had a couple of questions with the top. From this portion, what can you take out? X. Okay, so we can take out an x and we're left with x squared minus 4. Now, can I factor this? Yeah. Okay. A times c is negative 4. B is 0. What two numbers will make that happen? We gotta work on our factors. Okay. So that means that the top portion is going to be written out as x times x minus 2 times x plus 2. In the bottom, we can take out a 4x and we're left with x minus 1. So the bottom piece is going to be 4x times x minus 1. Is there anything that we can cancel on the top and the bottom?
No.
Look again.
Yes.
What?
X.
X and x, right? We can cancel out all our x's. Okay. So that means that we're going to have a hole at x equals 0 and a vertical asymptote at x equals 1 because that's left over in the denominator. I'll give you a second to look. On the denominator, okay, so can the numerator be factored? All right, so 3 is going to stay in the top. In the bottom, we are going to factor, okay? So a times c is negative 9 and b is 0. What two numbers will make that happen? 3 and negative 3. So that's going to give us x plus 3, x minus 3. Can I cancel anything else? So there are no holes. So you're just going to put none. For the vertical asymptote, we're going to have at x equals 3 and negative 3. Why did I do both? Well, because both are left over in the denominator. Okay,